So you're building with RAG, Retrieval Augmented Generation. You already know it's a game changer. But what if your system could do more than just find documents? What if it could actually understand them? Well, that's exactly what we're going to dive into today. And the secret ingredient is metadata.
This quote right here, it just nails it. We're talking about moving beyond basic keyword matching. It's all about using the data about your data, who wrote it, when it was published, what project it's for, to give your AI the context it needs to deliver incredibly precise results.
And we're not talking about tiny tweaks here. The impact is huge. When you implement proper metadata filtering, you can boost your retrieval precision by a massive 20 to 40%. Think about that. That's a huge drop in irrelevant results and a way better experience for your users.
Okay, so how do we get there? How do we actually achieve that 40% boost? Well, it all starts with a plan. We need a metadata blueprint, a really clear strategy for what information we're going to capture for every single document in our system.
A good blueprint breaks everything down into these logical buckets. You've got identity, which is basically what is this document. Provenance tells us where it came from. Classification is all about what it's about, and structure helps us understand its layout. Together, they create this rich, detailed profile for every piece of content.
All right, so we've got our blueprint. Now, how do we actually get this information out of our documents? Well, for that, we've got a toolkit with 4 main ways to do the extraction, and each one has its own special purpose.
You can really think of these 4 methods as a powerful set of tools. We're going to start with the simplest, most direct ones first, and then work our way up to the more advanced techniques for digging out that valuable and sometimes hidden metadata.
Our first tool is the easiest one, for sure. This is the low-hanging fruit. We're just grabbing the basic info that the file system already knows. Its name, its size, when it was created. Simple as that.
And you can see right here just how easy it is. This little Python snippet uses a standard library to instantly grab those basic file properties: name, size, modification date. It's a super fast and easy win.
Okay, next up, we go one layer deeper. A lot of file formats like PDFs or Word docs actually store metadata inside the file itself. We're talking about fields like author, title, and subject that are just sitting there, embedded right in the document's properties.
And again, a simple library makes this totally doable. Here we're using PyPDF2 to just pop open a PDF and directly access its internal information. So if the author put their name in the document's properties, this code will pull it right out. No problem.
But what if a document is totally blank? No embedded data at all? This is where things get really cool. We can actually use a large language model as a kind of smart assistant to read the content for us and generate the metadata that's missing.
Now, the real magic here is all in the prompt. We're not just asking for a summary. No, we're telling the LLM to read the text and then give us back a clean, structured JSON object. This is so important because it gives us reliable, machine-readable output that we can just plug right into our system.
And finally, we have our most advanced tool. This one actually analyzes the document's visual structure. It doesn't just read the words, it understands the layout. It sees the headings, the paragraphs, the lists, and the tables, creating this structural map of the entire thing.
And tools like the unstructured library are absolutely perfect for this. This code, for instance, it breaks a document down by its elements. It can automatically find the main title, count the sections by looking for headers, and even tell you if there are tables or images inside, all based on the layout.
Okay, so we've extracted all this raw data, but we're not done yet. Just pulling it out isn't enough. To make it truly useful for filtering, the next really critical step is to refine it, clean it up, and standardize it so it's reliable.
Date normalization is the perfect example. I mean, think about it. People write dates in a million different ways. If you want to reliably filter, like show me everything from January, you have to convert all those messy formats into one single clean standard format. And beyond just cleaning, we can also enrich the data, adding new layers of context. This could mean classifying documents into useful buckets, like technical doc or policy, and we can even get an LLM to generate a list of relevant topic tags. It just makes our metadata that much smarter. Okay, we've done the work. We've got our clean, rich, structured metadata. Now for the fun part. This is the payoff, using all this data to build a truly intelligent and responsive retrieval system.
And this right here is what it's all about. Simple, powerful queries that give your users incredible control. With just one line in our filter, we can now ask for documents created only after a certain date.
Boom! You've instantly narrowed the search to the most relevant time frame. But we can take it even further than just filtering. We can use metadata to intelligently rank the results we get back. We can boost documents that are more recent or maybe come from a more authoritative source and push them right to the top of the list.
So how does this actually work in practice? Well, take a look. A document might have a really good base score from its content similarity, right? But then we can apply a recency boost that nudges its final score even higher, making it surface above older, maybe less relevant information.
So, to bring it all home, here's a practical 6-step checklist to guide you through this whole process. Following these steps will take you all the way from the initial planning stage to deploying a really sophisticated, metadata-aware ranking system that truly understands your data.
And, this is the question you should ask about your own system. Any RAG application can store documents. That's the easy part. But by systematically extracting, cleaning, and using metadata, you're building a bridge from just having data to having true data intelligence. You're giving your system the power to understand context. And really, that's the difference between a good RAG system and a great one.